Okay, this one's admittedly a kind of a geeky presentation. Spatial Reasoning 101 is a look at what modern neuroscience says about how brains think about things when they're looking at something like a map or a graph. Uh, it's a brief review of research aimed for social studies teachers. So, centuries ago, Immanuel Kant said that humans have several built in ways of organizing information from experience. He said temporally, spatially, causally, quantitatively. He called them a prioris, meaning they're in our heads before we start learning anything. And for many years, schools have organized curricula around Kant's ideas, even if they're not aware of that the fact that we've got separate disciplines called history, geography, science, and math is basically Immanuel Kant's view of the way knowledge is broken apart in our head. And then the dark clouds came. And they showed up at the early beginning of the 20th century. Well, actually, earlier than that, all the way back to Descartes and dualism, and then behaviorism and Skinnerianism and utilitarianism and ism and ism and ism and this ism. Uh, all of these isms have one idea in common, and that is the human brain is a blank slate, and we construct knowledge on that state, right? You guys know about constructivism, and it's supposed to be the way the brain thinks. And then along came brain scanning technologies. Now, I've got to do a little aside here. Unfortunately, brain science has really become a buzzword these days. You know, you get all kinds of people peddling all kinds of pedagogical snake oil and calling it brain science, you know, brain friendly reading curricula and so on. Uh, At the same time, there actually is some research. And if we look at the real research, not just the publisher's ads, the real research, it says Kant was right. You know, we do organize in particular ways. According to Steven Pinker, in a pretty good book called The Stuff of Thought, he says what the mind contributes is a set of abstract conceptual frameworks that we have built into our heads that organize with space, time, causation, quantitative, and so on. This has implications for how we teach social studies and math and science. And uh, we've reviewed about 4,500 of these research studies and come to the conclusion that the brain seems to have at least 8 distinct networks that organize spatial information in different ways. I'm going to run across these words a dozen more times from now, so don't try to write them all down now. But this is available as a handout on the website that we'll show you later. These different brain networks, and they are all the way from above your left eyebrow to the back of the right-hand side of your head. They're in different places, and they light up when we think about sizes, shapes, positions, motion, other spatial ideas in different ways. Spatial comparison, when we take a look at two different places and think about how they're similar or different. Just think about the room we're sitting in right now. Would you call it large or small? Is it bright or dark? Dirty, clean, crowded, empty? You know, it's a lot easier to describe it if you think about it in comparison to another room. Compare it to your bedroom or to a gymnasium. Now, is this room bigger or smaller? These comparisons happen basically on the left side of your head, kind of behind your ear. And a map can help us compare places at very many different grade levels. I mean, what kind of comparison should we be teaching children to do with a simple map like this in second grade, or maybe in sixth grade, or in high school? How do you compare the peninsulas? You know, in second grade, you could say the UP is about half as big as the lower peninsula. A size comparison. The lower peninsula is more crowded. It's got more dots on it. A number comparison or numerosity. The southeast part of the lower peninsula has more people. Now we're dividing it into regions. The density of dots goes down faster as you go north from Detroit, as opposed to when you go west from Detroit. That's gradient. And those four ideas there are operating through four distinctly different brain networks. And your brain does all of them automatically. There's good reason for that. I mean, it keeps you alive if you're a small animal facing a great big tiger somewhere. But you're not likely to be aware of them all unless you verbalize them. And adults know how to do that. They know how to push from one network to another. Young children don't. So you need to encourage children to make comparisons in different ways. That's take home activity idea number one. I got 8 of them. Students have to learn how to use these networks. Let me show you a middle school current events topic with really deep historic roots and citizenship implications. 22,000 civilians were killed in Afghanistan since 2002. 46,000 civilians are dead in an ongoing conflict in Pakistan. Which place is more dangerous if you're a civilian? What do you need to do to make a fair comparison? And in this case, you need to adjust for population because Pakistan has a much larger population than Afghanistan. So your deaths per million people in Afghanistan are almost 4 times as many as they are in Pakistan. Meanwhile, a place like Shanghai is extraordinarily safe that way. And you wonder why I've got a blue bar at the bottom here. I'm going to erase the bar. Chicago is actually twice as dangerous as Afghanistan for a civilian. You're twice as likely to get killed. And what about Gaza? In other words, adult voters should learn how to make valid comparisons in order to be an intelligent voter. Now, that's just one of 8 different ways in which the brain is processing information. A second network is grouping things together into similar places. If you take wherever surveyors found pine trees in Michigan, back when they were doing the survey in the 1830s, like that, and then draw a line around the groups of pine trees like that. This is the kind of map that you're likely to see in a textbook about Michigan's pine belts. And it's very helpful to have kids draw lines around regions on dot maps like that, because it will help them understand how the map like this was made. Spatial pattern. Things are arranged in bunches, lines, arcs, rings, or other arrangements is another brain network. It's separate from the region network. If you make a map of earthquakes, you could draw some lines and we come up with a word like the Ring of Fire to have the lines of earthquakes around the Pacific Ocean. And the take-home activity idea is kids should be giving names to patterns that they see. And these could be patterns as simple as trees in a playground, cars in a parking lot, all the way up to things that they see on a map, like, forts during the Revolutionary War. Another brain network is thinking of what things that are smaller things that are inside of bigger things. Like Escanaba is inside of Delta County, which is inside the Upper Peninsula, which is inside Michigan, which is inside the Great Lakes states, which is inside the United States. So the take-home activity idea is to push students to name a big thing that's something that they're studying is inside. Things that occur together are processed through, you guessed it, another brain network. This one's just in front of your right ear, and it's what associates things that occur together, like the gas wells of Michigan that occur together with the Antrim Shale, because that's the rock that stores gas. And wherever the Antrim Shale exists, you're likely to find some gas. we've created a whole set of clickable maps that I'll show you at the end of this presentation, the website where they can make these associative comparisons. Over a lifetime, the more of these mental maps you have in your head, the easier it becomes to learn from new maps because you can see new associations. We're up to about, I think, number 6 out of 8 is the notion of a sequence. This is processed in the front side of your head, how things change when you go from one place to another. Like, how does the rainy days in Africa change as you go from the equator up to the northern part of Africa? Very often, textbooks will show this with a region map, but you actually process those two maps through separate brain networks. Here's the kind of research that we see about that, and you notice what we're talking about. This is individual differences. Some students find it easier to remember a region map. Others find it easier to think of Africa as a rainy sequence that goes from very rainy to very dry. And I could have done this all the way along here. I just wanted to preserve you a little bit. Like I say, there's 4,000 of these studies. And for every one of these comparisons, there's been a half dozen articles about that difference. So there's going to be more studies that talk about things that are close to but not within, or not between, things that are next to a power plant like this. And the take-home activity idea is to push students to think, is there some place that could be influencing the place someplace nearby? What's the effect that Detroit has on some of the suburbs around it? And the last of these in this list, and like I say, I'm not sure that this is the list. There may be 9 of these, there may be 11. But the last on this list is the notion of a spatial analogy, being in a similar position but not close to. Like, take a look at lake effect snow. Muskegon is like Buffalo. Both of these are in a similar position on the east side of a big lake, and therefore both of them get a lot more snow than other parts of their state do, but they're pretty far apart. And there's a lot of these. Miami is like the Philippines. They both get hurricanes. Well, before I leave the map of snow, it's a really good illustration of a key idea that people can, and frankly, they often do, use different modes of spatial reasoning with the same map. That you could take a look at a map of snow and you could think of it as an aura, snow occurring near the lake. Or as a region, there is a region of heavy snow in the west side of Michigan. Or as a gradient, a transition. There's less and less snow as you go east across the state. Or it's an analogy. It's like upstate New York. Different people will use it. Here's a good analogy. The modes of spatial thinking are like the different muscles in your arm. You're likely to use different combinations of muscles to play a piano or saw a board or throw a baseball or whatever. You're likely to use different modes of spatial reasoning to read maps of different topics or to answer different questions when you look at a map. And it takes practice to learn how to do any of them well. So there's 4 messages for you to take home. Number 1, human brains do have built-in ways of organizing information. And we now know that they've got at least 8 different ways of organizing spatial information on the things you see on a map. Different people may actually prefer different modes of thinking, and therefore they're likely to see different things even when they look at the same map, unless you really know how to ask the question to push everybody to see the same thing. With guidance, however, everybody can learn how to do every kind of spatial thinking better. And if you know how to use several different modes of thinking, it's much more likely you're going to be able to remember that map. So it's basically you're learning how to learn when you're learning these different modes of thinking. And I should warn you, concentrating on the modes of thinking that you personally find most useful could actually discriminate against some of the students in your class, meaning you have to learn how to learn too. So, different modes of spatial thinking are associated with specific prepositions and trigger words. And on the website, we've got a page of trigger words that are shown to trigger using particular modes of thinking. One of the websites is one called ourspatialbrains.com. And you just have to kind of nose around in there. It's got student activities, it's got idea geography, it's got learning progressions. What do you do in early grades and later grades? Got all kinds of cool stuff.